Hi ladies, this is Mrs. Blaufuss. This is Geometry Lesson 1.2, and in this lesson we're going to look at finding angles. So here are your key terms for this lesson. We'll define them as we go through the lesson, and anything that you still have not defined, please use your glossary in your textbook. So the first thing we're going to define is angle and vertex. An angle is formed by two rays that are non-collinear. So remember, a ray has an endpoint and goes on forever in one direction. The idea that they're non-collinear means they share, they go on in different spaces. Okay, so these are two separate rays. They share an endpoint, so the vertex is the common endpoint of the two rays, but they are two separate rays. Something that you should note about an angle is it's measured in degrees. And that it's the shortest degree measure between the two rays. So when we measure this angle, it would be this distance between these two rays. This distance between these two rays is called the reflex angle measure. And that is the longer or the larger distance between the two rays. The reflex angle measure will always be less than 360. So if you look at your notes sheet, oh, we talked about reflex angle. So again, that's the longer distance between two rays. It's still measured in degrees. So if you look at this example, we can see the vertex is here, point A, that's the common endpoint of the two rays. And the two sides of the angle are the rays. So this is side AT, and this is side AP. And again, those sides are made up of rays. So we're going to name the same angle. We're talking about this angle right here. We're going to name it three different ways. When you name an angle, the vertex always has to be the center. So the first way we can name this angle is here is our angle sign. So we could say angle TAP. Okay, A is the vertex. The vertex is in the center of our name. Now the same angle, we could name angle PAT, where A is still in the center of our name because A is our vertex. And then the last way we can name this angle is angle A. We can use a single letter only when there is one specific angle at that vertex. So if you look at the next couple diagrams, it asks you to name all of the angles in this drawing. So I'm going to go through and name all of the angles, and some of them have more than one name. Okay, so the first angle that we're going to talk about is right here. This angle made up of ray UR and UV. In this diagram, UV is a segment. So a segment can also be a side of an angle. So this angle I can name angle RUV. I could name it angle VUR. I could name it angle 1. because there is a number inside of that angle. That's a label. I could name it angle 1. But I cannot name it angle U. Angle U does not work because if I say angle U, I'm not sure if we're talking about this angle, maybe we're talking about this angle, or maybe we're talking about this angle. Okay, since there are 3 potential angles at vertex U, I have to use 3 letters or the given number label. All right, the second angle, let's talk about this angle right here. So this was our blue angle that we named. All right, so the angle that I have highlighted in red, let's name that. We can either name it angle VUT, angle TUV, and those are really the only 2 options. Again, I cannot name it angle U because there's more than one angle at that vertex. Looking at another angle, let's look at that big angle right there. I could name it angle TUR. I could name it angle RUT. But I cannot name it angle U. Again, because those are the 3 angles, there are 3 angles that meet at vertex U. This angle right here, I have 3 names. I could name it angle T, just angle T, because here there's only one potential angle at vertex T. So I could name it angle T, I could name it angle UTV, or angle VTU. And then my last one, right here, I could name angle V because there's only one potential angle at this vertex. I could name it TVU, or I could name it angle UTV. So take a minute on your own to do this next angle, or this next example. Name all of the angles. There are 3. There are 3 angles in this diagram, and there are multiple ways you can name it. So please pause the video while you work and unpause for the solution. So in this next diagram, we have angle XAY or angle YAX. We cannot say angle A, because if I say angle A, I don't know which of those 3 angles at vertex A we're talking about. Okay, so I have to, in this diagram, for all 3 angles, I have to use 3 letters, and for all 3 of them, all 3 angles, no matter which way I name it, A is in the center, because A is the vertex of all 3 of those angles. In this next example, and you can go ahead and try on your own paper, mine may not be exact, but they're pretty close. So use a protractor to measure these 3 angles. And if you have trouble with your protractor or you don't know how to use the protractor, please come and see me and we will get everyone on the same page. So this is just an example practicing with your protractor and reading angle measures using degrees. And remember that you're measuring the shorter distance between those 2 rays. A couple new terms. 2 angles are congruent. If they have equal measures. This IFF, so the if with 2 F's, means if and only if. Okay, that means the if and the then part of the statement are true. So we could use what's called a converse. We could say if 2 angles have equal measures, then they are congruent. Okay, so IFF means if and only if, and that means the if part and the then part are true no matter which order you read it in. Okay, so two angles are congruent if and only if they have equal measures, or two angles that have equal measures are congruent. And then we have a new term called the angle bisector. And the angle bisector is a ray that goes through the vertex that cuts the angle into two congruent pieces. We can tell that angles are cut into two congruent angles by this congruent marking. So in this class, a lot of times you'll see congruent angles marked with an arc and then a tick mark, or an arc and two tick marks. Okay, the number of tick marks are going to correlate to congruent angles. Or you may also see it in other contexts with simply just an arc. Okay, so one arc means it's congruent to another angle marked with one arc, or two marks correlate with another angle marked with two arcs, symbolizes congruence. So if you turn your note sheet over and you look at the back, we're looking at these three diagrams, and the first question is name each angle bisector and the angle that it bisects. So remember, an angle bisector, it cuts an angle into two congruent angles, and to be a congruent angle, they have to have the same measure. Okay, so this GE, these two are not the same measure, therefore those angles are not congruent, therefore GE is not an angle bisector. But here, we have this angle cut into two congruent angles. They both measure 52 degrees. So we can say that RP, and again, it's a ray, so make sure when you label it, you start with the endpoint. So RP is the angle bisector of angle SRQ. Or you could also say RP is the angle bisector of angle QRS, as long as R is in the middle of your name. And the last one, although we have two angles here, there is not one single ray that forms those two congruent angles. Okay, so in the last diagram, there are no angle bisectors. The second part asks to name all congruent angles in the figure. Make sure that you label it so there's no question about which angle you're talking about. So for example, I would not want to say angle R because there are three angles at angle R, and I'm not sure which one you would be talking about if you just said angle R. Okay, so we'll use three letters where the center letter is our vertex. So name all congruent angles in the figure. In this figure, there are no congruent angles. In the second figure, we have angle SRP is congruent to angle PRQ. Okay, and again, you can label them in reverse order as long as R is in the center. And then in the last diagram, we have angle YMN is congruent to angle OME. Okay, and for both of these, M should be in the center. So we're saying this angle is congruent to this angle. And you can see that by the congruent markings. Okay, and then the last concept in this lesson is angle addition. So here we have an if-then statement. So angle addition, using this diagram, says that if point B is in the interior, point D is in the interior of angle CAB, it's somewhere in the middle of that angle, then angle CAD angle CAD plus angle DAB is equal to angle CAB. So this is similar to the segment addition that we worked with last lesson, but now we're looking at pieces of an angle. All right, and then one more example. You have a slice of pizza with a central angle that measures 140. That's this angle right here. That you want to share with your friend, and she cuts it through the vertex into 2 slices. So she cuts it into 2 pieces, and you choose the slice that measures 60 degrees. The whole angle measures 140. You choose the piece that measures 60 degrees. The question is, how many degrees are in the other slice? So let's look at the whole thing. 140 degrees is equal to the 60 degree slice that you chose plus, we'll just call it X, the X degree slice that your friend chose. So we're going to just use algebra to solve. And to use algebra, we subtract the same value from both sides. And we get 80 degrees is equal to X. Therefore, the slice of pizza that your friend chose measures 80 degrees. So please jot down any notes or questions that you have and come with them to class next time I see you. Thank you.